Welcome to Apex Science Academy. In this video, I'll go over the math problem we posted last week. This is a problem we designed to demonstrate the use of diagrams in solving math problems. Let us read the problem together. A man is running through a train tunnel. When he's 2/5 of the way through, he hears a train that's approaching the tunnel from behind him at a speed of 50 miles per hour. Whether he runs ahead or back, he will reach that end of the tunnel at the same time the train reaches that end. At what rate in miles per hour is he running? So how do we solve this problem? To solve this problem, we're going to draw some diagram to help us visualize the problem. I have made a sketch of the problem, and what you see here is a straight line that represents the train track. And A and B mark the locations of the two ends of the tunnel. T and R mark the locations of the train and the runner. When the runner hears the train approaching, let's assume the distance between A and B is L1, which is also the length of the tunnel. Let's further assume the train is at a distance of L2 from point A initially. The question says that when the runner first hears the train approaching, he is 2/5 through the tunnel, which means the distance between A and R is 2/5 of L1. Now, based on the question, the runner has two options of running. The runner can either run toward A or toward B. Either way, the runner and the train will reach that end at the same time. Let's look at the situation when the runner is running backward toward A. So this is the direction of movement, and this is the direction of movement for the runner. So the question says, when the runner runs backwards, the train and the runner will reach point A at the same time. So which means it's going to take the same amount of time for the train to go from T to A and for the runner to go from R to A. So let's calculate the amount of time it takes for the train and the runner to reach the point A. We know that time is equal to distance over speed. So the amount of time for the train to go from T to A is going to be distance L2 divided by the speed of the train. The amount of time it takes for the runner to go from R to A is going to be the distance 2/5 of L1 divided by the speed of the runner. Let's say VR. So these two are equal. So we get the first equation that relates the speed of the train and the speed of the runner. So we're going to draw a box to highlight that result. So here, what we have here is an equation that contains one known parameter and 3 unknowns. Obviously, this is not enough for us to determine the speed of the runner. But we also know that when the runner is running toward point B, the train is also going to reach that point at the same time. Let's find out the amount of time it takes for the runner and the train to reach point B. In that case, I'm going to change this arrow. So how long it takes for the train to reach point B from T? Well, the idea is the same. It's going to be distance over the speed. So the total distance between T and B is L2 plus L1. And if we divide that by the speed of the train, it'll give us the time it takes for the train to go from T to B. How about the runner? So when the runner runs from R to B, the total distance is going to be L1 minus 2/5 of L1. And then we divide this by the speed of the runner. And we know that these two will be equal. So now we have another equation that relates the speed of the train and the speed of the runner. Let's draw a box to highlight this equation. Now we have two equations that relate to the speed of the train and the speed of the runner. Let's see whether we can use these two equations to determine the speed of the runner. Let's copy this and move to the second page. So what we notice is that if we subtract equation 1 from equation 2, we're going to get L2 plus L1 over Vt minus L2 over Vt equals VR L1 minus 2/5 of L1 minus 2/5 of L1 divided by V sub R. Now, if we simplify this, we'll get the left-hand side. The left-hand side will be L1 over Vt. Oh, this should be Vt. The right-hand side will be 1/5 of L1 over V sub R. Now we have a simpler equation that relates the speed of the train and the speed of the runner. And if you do some simple rearrangement, you will find that the speed of the runner is 1/5 of the speed of the train. And because we know that the speed of the train is 50 miles per hour, and that tells us the speed of the runner is 1/5 times 50 miles per hour, and then which yields 10 miles per hour. And that's the speed of the runner. Okay.